Previously, we have seen the reflection through the lines that pass through the origin. Correct? We have seen the reflection through x-axis, reflection through y-axis, reflection through origin or reflection through y is equal to x line or reflection through y is equal to minus x. So that reflection we have seen previously. Here. Here, this example we have seen previously that reflection through x-axis, reflection through y-axis, reflection through all these points we have seen previously. But now we are going to see this one. Reflection through x-axis, y-axis, y is equal to x line, origin, and y is equal to minus x line. It is third one is the origin, and y is equal to x, y is equal to minus x. But now we are going to see the reflection through an arbitrary line. Now, when we see the reflection through an arbitrary line, again we need to follow the steps. There are 5 steps when we perform the reflection of an object and arbitrary line. Object, again it may be line, triangle, rectangle, square, point, any. So the 5 steps are that the first, translate the line and the object so that the line passes through the origin. We are doing the reflection through an arbitrary line. The line may be y is equal to mx plus b, any line, not necessarily passes through the origin. So first translate the line and the object so that this line passes through the origin. First step is that. Second, rotate the line and the object. Here we are performing. First, rotate the line and the object about the origin until the line is coincident with one of the coordinate axes. Okay, x and y axis. Normally, x axis is used. Rotate the line. First, translate it so that it passes through the origin. Then rotate the line and the object given. It may be triangle, rectangle, anything about the origin until the line is coordinate with the x-axis or y-axis. Normally x-axis is used. So rotate it as per required so that it is coincident with the coordinate axis. Then the reflect it using the coordinate axis through that axis, x-axis if it is, reflect it. Then rotate back about the origin, means we have rotated it to make it coordinate or coincident with the x-axis. And for that we need to rotate it back, means reverse rotation we need to do here. And then originally we translate the line and object so that it passes through the origin, means again we need to perform the inverse translation also. Inverse rotation and inverse translation. See again, first translate the line and the object so that it passes through the origin. Okay. Rotate the line and the object. We need some rotation until it is coincident with the axis. After that, reflection is given. Reflect through that axis, coordinate axis. Suppose for example x, reflect it. Then rotate back, means perform the inverse rotation. We have rotated here. So with that angle only rotate. And then initially we have performed the translation. We translate it from its origin. So for that we require to perform the inverse translation. And therefore the transformation matrix for this is T is equal to the first translation matrix, this one passes so that it passes through the origin. Then the rotation, so it should be coincident with the coordinate axis. Then inverse rotation, it's a reflection, and then inverse rotation, inverse of this R, and inverse translation. Inverse rotation and inverse translation. Here, dash. So these 5 steps we need to do here. Now see the example. These 5 steps we are going to follow with this example. So first consider the line L and a triangle ABC. Consider a line L and triangle ABC with equation of line we require y is equal to 1 half x plus 4. 1 half x plus 4. And the triangle coordinates are ABC is equal to 2, 4, 1, 4, 6, 1, 2, 6, 1. I'm going to draw it here. So up to 6. It is 2, 4, 2, 4. A may be here. Then 4, 6, 4, 6. B and 2, 6. 2, 6. Here it is C. That is our triangle. And the equation of line is y is equal to 1 half x plus 4. So it is the y-intercept. What is the y-intercept of this line? Y is equal to 1 half x plus 2. So I draw it rough line. It is not actually the correct one, but it's like this. Y-intercept is plus 2. So this is our line L and this is the triangle ABC. Now we want to reflect this triangle through this arbitrary line. It is not passes through the origin, correct? So we need to reflect this triangle through this line, arbitrary line with the equation y is equal to 1 half x plus 4. Now the first step. What we require in the first step? We follow one by one the steps. What is the first step? First we need to translate it. What is the first step? Translate line and object so that it passes through the origin. So that it passes through origin. In this way we need to translate. Means this 2 y-intercept we need to make it 0 passes through the origin. For that purpose, what is the value of m and n? For that purpose we need to translate it, correct? So that it passes through the origin. Means what? We need to translate it minus 2 units in the y direction. We need to translate it minus 2 units in the y direction. Not necessary to change the x direction. Only we need to translate it from here to here. Means minus 2 units in the y direction. X not necessary to change. So to translate this triangle and the line m is equal to 0 and n is equal to minus 2, then the transformation matrix or the translation I write it directly. Then translation is our triangle 2, 4, 1, 4, 6, 1, 2, 6, 1. And the transformation matrix is 1, 0, 0, 0, 1, 0. Here we write the value of m and n. Correct? Here we write the value of m and n. So in this case, it is 0 and it is minus 2. M is equal to 0 and n is equal to minus 2. Now perform the multiplication. It is 2, 2, 1, 4, 4, 1, 2, 4, 1. That is, we translate the line and the object passes through the origin. Now here -2 means the line comes here. It passes through the origin. I draw here again. If I draw it within the same, it will be confusing for you. That's I'm going to draw it again. Now it passes through the origin. Correct? So triangle is now 2, 2. This is now A. 4, 4. 4, 4. Somewhere it is B. And 2, 4. It is C. This point is C. Now you can observe here. This point Y is changes by -2. Y is changes by -2, and this is our new triangle, or the position of the triangle, new position of the triangle. It is translated so that the line passes through the origin. Only translation of the line is not sufficient. We need to translate the object also. After that, the next step. The next step is that we need to rotate the line and the object. Correct? We need to rotate the line and the object so that it is coincident with any one of the rotate line and object, so that it coincident with x-axis. Here we consider x-axis, and normally we consider the counterclockwise rotation. Now we want to rotate this line, correct, and this object so that it is coincident with this x-axis. Means what we need to do? We need to rotate with this angle theta. We need to rotate it with the angle theta so that it becomes coincident with the x-axis. Only line rotation is not sufficient, and that's why we are going to rotate the object also. Now here what we need to for the rotation? We need this angle. What is this theta? Now how to identify this theta? It's a simple method. To identify this theta, we need to find out the slope of this line. We need to find out the slope of the line. Using the slope, it is very easy to identify the angle theta. So, need to identify angle theta so that we can rotate it. The simple equation of it is m is equal to tan theta, tan minus theta in counterclockwise. So, m is equal to minus tan theta, and theta is equal to minus tan inverse m. Okay. So, how we calculate the theta? Minus tan inverse m. What is our m here in this equation? Y is equal to 1/2 x plus 4. 1/2 m is equal to 1/2. So theta is equal to minus tan inverse 1/2, which is equal to, if we calculate it with the calculator, theta is equal to minus 26.57 degree. Theta is equal to minus 26.57 degree. So here it is minus 26.57 degree. We need to rotate this line and the object so that the line becomes coincident with the x-axis and we can reflect the object. Now we need to write the equation or the transformation matrix for rotate. Now rotate the line and object with angle theta is equal to minus 26.57 degree. So the value result is 2 4 2 sorry 1 4 4 1 2 4 1 multiply with transformation matrix. So it is cos theta sin theta minus sin theta cos theta, that is the transformation matrix counterclockwise rotation. So I write here cos minus 26/57, here sin minus 26/57, then minus sin minus 26/57, cos minus 26/57. That is our transformation matrix T for the rotation with the angle theta minus 26.57. Now try to calculate it. Cos minus theta is equal to cos theta. We know that. So accordingly, the result is 221,441,241 multiply with, using the calculator, the values are 2 by root 5 minus 1 by root 5, 0, 1 by 5 root 5, 2 by root 5, 0, 0, 0, 1, which is equal to 6. Multiply this one with this one, we will get 6 root 5, 2 root 5, 1, 12 divided by root 5, 5 divided by root 4 divided by root 5, 1, 8 divided by root 5, 6 divided by root 5, 1. Now we want to draw the triangle to see the result, and for that I convert it into the point so that we can draw it. 2.68, 0.89, 1, sorry, 5.36, 1.78, 1. Already I have done these calculations with the help of calculator. 1. Okay. Now I am going to draw it here. First A is now 2.68. It is somewhere here, and 0.89. Not exactly, but it is somewhere here. Then B is 5.36 and 1.78. 1.78, 5.30. It may be here something. B. And C is 3.57. It is somewhere here, and 2.68 means it is somewhere here. Okay, so that is our new position or location of the triangle. Now line is coincident with the x-axis because that line, previous line, this one we have rotated it now. So it is coincident with the x-axis, and this triangle is also rotated by minus 126/57 degree, and we will get this result. Now the rotation is complete. Third one is completed. Now the next task. Sorry, second task is completed. Now the actual we want to reflect it. reflect through x-axis. This triangle reflect through x-axis. So the transformation matrix is here. You can use this one or this one, any one for calculation. Instead of that, I will use this one, second. 2.68, 0.89, 1, 5.36, 1.78, 1, 3.57, 2.68, 1. Now here we require the transformation matrix to reflect through the x-axis. So reflect through the x-axis means y is equal to -1, 1, 0, 0. The standard transformation matrix is there, that already we have seen. It is like this for reflection through the x-axis. That is our t. Here also it is our t is equal to x remains as it is 268, 5.36, 3.57, only minus 0.89, minus 178, minus 2.68. Now I draw it here only to see the result. -1, -2, -3, -4. What is the first? 2.68 and minus 0.89. So it is somewhere 2.68. That is our new A, or we call it as a star. Then 5.36 minus 1.78. It may be somewhere here, B. And 3.57 and minus 2.68. It is somewhere here, C. So what we observe that now this triangle is reflected with x-axis. This triangle is reflected with the x-axis. But whether it is a final result? No, it is not a final result. Why? Because first we translate the line so that it is through the origin. Then we rotate it with angle theta so that it is coincident with the x-axis. Now we need to do it in reverse. First we need to rotate it back and then translate it back. So inverse rotation and inverse translation we need to apply. That is our fourth step. Apply inverse rotation. Apply inverse rotation. Theta is equal to, now that is using the same value, minus 26/57, but inverse rotation now it is. 6 divided by √5, 12 divided by √5. The previous result we are rotating, reverse. Minus 2 by √5, minus 4 by √5, and the last minus 6 by √5, 1, 1, 1. Now multiply it with the transformation matrix, which is the inverse of the previous one, which is inverse of the previous one. 2 √5 1 root 5 minus 1 by root 5, 2 by root 5. 0, 0, 0, 0, 1. That is inverse of the previous one. You can see here. This one. So that is inverse now. It is here. Now the result is equal to 2.8, 0.4, 5.6, 0.8, 4.4, 0.8. Now I'm going to draw it here. The result 2.8, it is minus 0.8. So 2.8, 0.4, 2.8, 0.4, it is somewhere here. That is our new A. 5.6, 0.8, 5.6 and 0.8. 4 means it is here. It is here. B and 4.4 and minus 0.8. That is our new ABC. Now observe it. This one now rotated back. This red triangle, the triangle drawn with the red line, it is now rotated back. So that is our new one. And the last one, we need to translate it back with again unit 2 by y direction only. In the previously we translate it only y direction. Correct? We translate it only y direction. X direction is not translated. So again we need to perform the reverse translation with y direction only. So our last translate back to original location. With m is equal to 0 and now n is equal to plus 2. Instead of minus 2, now it is plus 2. So apply this on this result. 2.8, 0.4, 5.6, 0.8, 5.4 minus 0.8, 0, 0, 1. And the transformation matrix is m is equal to 0, 1, 0, 0, 0, 1, 0, 0. Now instead of minus 2, here we use plus 2 and perform the multiplication. The result is 2.8, 0.4, 5.6, 2.8, 4.4. Now only change it. Instead of minus 0.8, it becomes 1.2. And that is our final triangle. That is our final result. So I draw it here. 2.8, okay, along with 0.4, sorry, all are increased in y direction. 2.4, 2.8 and 1.2. So 2.8, 2.4, 2.8, 2.4. Here it is A star, we call it the final one. Then 5.6, 2.8, 5.6, 2.8, it is somewhere here, B star, and 4.4, 1.2, 4.4, 1.2, here it is C star. That is our final result by applying all these 5 steps. In matrix notation, we know that already here it is like this, correct? This we have done. Translation, rotation, reflection, inverse rotation and inverse translation. So all these things can we do together? We have seen one by one, correct? Why? Because it is easy to see the result one by one how this is performed. But this one also we can do in one step because we know this one. If we know the transformation matrix, first translation, then rotation, then reflection, inverse rotation and inverse translation. Inverse rotation and inverse translation. Now, in this example, that previous example, if we write all these transformation matrices together, then our final T is the first translation we perform with -2, 1, 0, 0, 0, 1, 0, 0, -2, 0. That is m is equal to 0, n is equal to -2. That is our first translation. First step. Then second transformation matrix is for rotation about some angle theta. That is 2 by root 5 minus 1 by root 5, 0, 1 by root 5, 2 by root 5. That is our R, rotation with angle theta. Next is reflection. It is a reflection, that is R dash R dash, that is reflection through x axis, reflection through x axis. So this is the transformation matrix. The next transformation matrix is inverse of this R inverse. So 2 by root 5, 1 by root 5, cos theta is minus theta is equal to cos theta. Minus 1 by root 5, 2 by root 5, 0, 0, 0, 0, 1. That is the fourth transformation matrix. And the next, it is inverse rotation. Inverse rotation. Then the last, inverse translation. Here m is equal to 0, n is equal to 2. That is inverse translation. And then we can concatenate all these transformation matrix together. The result will be is like this: 3 by 5, 4 by 5, 4 by 5, minus 3 by 5, minus 8 by 5, 16 by 5, 0, 0, 1. That is the entire transformation matrix. Simply, this one you can multiply with the original object x multiply with this t. The original object is our triangle 2, 4, 1, 4, 6, 1, 2, 6, 1. And this transformation matrix 3 by 5, 4 by 5, minus 3 by 5, 0, minus 8 by 5, 16 by 5, 1, which is equal to 14 by 5, 12 by 5, 1. Or if we simplify it, write it in the decimal, it is 2.8, 2.4, 5.6, 2.8, 4.4, 1.2. That is our final result. If you observe the previous one, it is there. So all these 5 steps you can perform within a single step also, but you need to write the transformation matrix very clearly. Transformation, these 5 matrices are very important here, and the multiplication of this is also important. If anything wrong with that multiplication, the result will be wrong.